So actually, I had a few questions about a little bit of the organization of the course, so I wanted to talk about just a few things briefly before we get started. I think most of us are on the same page, but just in case there's more confusion out there that I'm not aware of. The difference between Piazza and Discord, I have my quick one-liners on the syllabus on the course website. Piazza is where you can ask questions, and also the office hour schedule is there, so you can find office hours. And then Discord, meant for you to be able to chat with other students. Discord isn't meant to be the place to ask coding questions. I'm fine if you do that. I encourage that even. You know, that's perfectly fine. You can talk about the assignments and your experiences in the class and the code, and as long as you're not violating academic integrity, that's perfectly fine. But you shouldn't expect the TAs to be answering questions there. Some of them do. They do out of their own volition, but I tell them that they don't have to do anything on Discord. Discord is the place for you to just kind of hang out and chat. It's supposed to be a very casual environment. It's a place where I just kind of let things go. Whatever happens on Discord kind of just happens. I'm fine with whatever happens there. So if you notice like the TAs acting ways that you didn't think TAs would behave, doing things that TAs wouldn't necessarily be doing or maybe shouldn't be doing, that's perfectly fine, because in Discord they can just be themselves. They're not necessarily TAs. They have the TA roles. Some of them hold office hours. They have official capacity on Discord. During lecture, they have official capacity on Discord where they're being TAs. But if they're acting crazy and posting memes and stuff, you know, they're just students too. They're just being people. They're just being human beings. If you want us all to be professional, that's Piazza. Piazza's the place for that. If a TA's, you know, being strange on Piazza and posting things like they do on Discord, that's different. But I just want to put that out there that that's expected and perfectly fine. It's a place for you to interact with other students, TAs being other students. So things that I would encourage you to do on Discord, like ask the TAs what the future courses are like in CSE. They're going through that curriculum. They're just like you, but they're a few years ahead. They got here a little bit earlier. Ask them, you know, is 250 as hard as everybody says it is? How's 220? What should I expect in 220? Like, they'll have good answers for you, and they'll be happy to share it. But they have no expectation, at least for me, to be TAs on Discord. Everything that they do as a TA, answering your questions, that's just them doing that on their own. So I just want to clear that up. If they're not acting professional on Discord, good. They shouldn't be. They shouldn't be professional on Discord. Except like during lecture, they should be a little professional because I'm using it as an official capacity there. And review session. I'm going to remember today. I remembered it. Review session right after class every Wednesday. It includes today. Go to the Twitch channel. I don't think I'm logged into Piazza. Maybe I am. There's the view as student button. We'll just hide the sidebar. But there's, oh, they didn't even put it on the schedule. That's why. Is that why people aren't finding it? CC review session, the top pinned post. CC review session, there's the Twitch link every Wednesday, 3 to 5 p.m. Or if there's not a lot of traffic, sometimes they'll leave before 5 if they're just sitting there by themselves. Hopefully today a lot of you go now that I'm remembering to do this. But check that out. Go to the Twitch stream. Get in the chat. Ask questions. Get your questions answered. Go have them go through examples. If the example doesn't make sense, pressure them. Be like, that still didn't make sense. Help me out here. Jesse's example didn't make sense. Your example didn't make sense. Can you explain this in more detail? Can you explain this a bit better? And they'll be happy to go through it again. At least they better be happy to go through that again. I'm even going to good note it. So please go check them out. They only had, I think, 2 students last review session. So either the word just isn't out there because I kept forgetting to advertise it in lecture, or you all just really know the content. I don't really think it's the second one. As optimistic as I like to be, I think there's still a lot of confusion. These are very tricky concepts, and they come very fast. You just learned what a class was 2 weeks ago, and now you're expected to know inheritance, polymorphism, and the state pattern. Like, that's fast. We know that's fast. There's just a lot of ground we have to cover in this class. So go to review session, get that reinforcement, get those extra examples. The PyCharm on my, so IntelliJ, that's what I use for Scala and Java. PyCharm for Python, and then WebStorm for Node. These are the JetBrains suite of IDEs, and they have one for just about any language you want to use. You can go find the IDE for the language of choice. For Scala, IntelliJ is the answer. For JetBrains, obviously that's opinionated. There are other people who like other environments. VS Code is very popular these days. That's the one I have right here. For things that are not one of these three, or sometimes I just want to use VS Code, even for one of the languages for those IDs, I'll go to VS Code, which will give you a command line and everything. It'll give you, the command line, a place to edit your code. Looks very similar to IntelliJ, but way stripped down with features, and then you can add on features that you want with plugins. So it's much more customizable. Don't use Vim. Don't use Vim unless you really know what you're doing. Nicholas. There are people who swear by Vim. If you're new to coding, I do not recommend it. I don't even use it, and I've been coding forever. I'm not drinking the Kool-Aid on that one, but there are some people who swear by it. I don't know. Try to, you know what, whatever. You'll make your own decisions. Vim, for those of you who don't know, it's a terminal-based text editor. You can only use the keyboard, no mouse, and you have to memorize like pages and pages of keyboard shortcuts if you want to be productive with it. Once you memorize all those shortcuts, you can be very productive, so I'm told. But before you memorize those shortcuts, it's just a pain in the ass. Painful to work with. Is that an accurate summary of Vim, Nicholas? Not even paying attention. I'm talking about your comment. Didn't you comment about Vim?
Yeah, I said Vim. Well, I didn't say anything about Vim. I said
Okay. I take that as an endorsement. That's how I hear that. All right, any questions about the structure of the course or anything? Homework, whatever, before we get into some slides? And a reminder, this is one official capacity that I use Discord for. So TAs, if you can tone it down a bit in the lecture channel, please. If you want to ask questions during lecture, I'm watching the lecture channel. That is a place where I expect my TAs to be more professional and not say we in chat, not to call anybody out in particular. But let's get into this. Let's get into some slides. So I want to talk about GUIs today. This is something that I'll be upfront with you. I'm not going to ask you to write GUI code. So this can be more of a break from what we've been doing. In fact, after Monday's lecture, that was the last lecture that you need to complete all of Project 2. So all of Point of Sale, you have everything that you need for that. I'll talk about GUIs, but if you're really observant in the course, we can go to the syllabus, go to LO2, and nowhere in here do I mention GUIs. So guess what I'm not testing you on? GUIs. But I do give you GUI code in the homework handout. For this one and the next two, you'll be getting GUIs in the handouts. So I want to at least, I don't like ever giving code where you can't understand it, so I want to at least make sure that you're able to understand every piece of code that you see in this class. So that includes the GUI. We have this kind of GUI that works by magic in Point of Sale. I want to demystify that and show you what's going on with that. So for this, we use, and then if you want to write your own GUIs, you're empowered after this. You can actually make software with GUIs, and you're not just running your unit tests or calling a main method. You can actually make apps with, that look like the apps that you use every day. So to do that, we're going to use a library called ScalaFX, which is a wrapper for JavaFX. This is why we need both your versions of Java and your version of Scala to be accurate. It's mostly for this library. This library uses both Java and Scala and has to have the right versions. JavaFX used to be part of Java itself, and then they removed it at some point. It's a little bit of a mess, but as long as the versions are lined up, then everything's fine. So that's why for the first lab, we have you run that GUI, which is actually the last GUI that we'll go over as an example today, where there are spinning rectangles and a circle that moves around. That makes sure that all your versions are right because it uses everything in this library, everything that we need anyway. And then when you clone project 2, you don't get errors because we already fixed those errors in the first lab. So that's mostly this library. So ScalaFX is a wrapper for JavaFX. So you need both JavaFX and ScalaFX. ScalaFX adds Scala syntax to JavaFX, so we can use all the Scala syntax that we know and love. But most of the code that we're using in ScalaFX is actually JavaFX under the hood. ScalaFX translates the Scala to Java and then calls the Java code effectively is what it's doing. It's a wrapper class. The documentation for ScalaFX kind of sucks. It's just not really out there. There are some good resources, but it's very, very lacking. It's just not used enough to have enough of a community around it to generate all that documentation. ScalaFX does. ScalaFX has phenomenal documentation, examples all over the internet. It's fantastic. So what I recommend if you want to do apps, if you want to build GUIs and have more advanced features and learn more about them, look up JavaFX and get JavaFX examples. The code will be in Java, and then convert that code over to Scala, similar to how you saw JavaScript code for homework 1, and then convert it into Scala code. Similar to that, you know, your variable declarations are going to have to be val or var. Use Scala syntax, use the arrows when needed to do loops and things like that. Convert the syntax to Scala, and then you can use those examples if you want to use any examples out there for this. That's what I recommend. You can try to just stick with the ScalaFX examples, but you'll find a wealth of resources if you start looking at JavaFX. All right, so let's build our first GUI. We're going to build this degree converter. We're going to type in some degrees in Fahrenheit. We're going to click this big old button, and it's going to tell us those degrees in Celsius. I punched in 62, click this button, and my code spat this out on the other side. So let's build this. It's a lot of Java and Scala all at once. Yeah, it is. So let's build this one line at a time. Before we get to that, there's syntax that's used extensively in ScalaFX for initializing values of state variables. That's this initializer code. So let's talk about what the syntax is with a simple example before we start seeing it everywhere in our GUI examples. So for this, when we create a new object, after the argument list, we're going to add a block of code. We're going to have these braces, add a block of code, and then initialize any extra values that we want to initialize. This code effectively runs after all of the initialization in the constructor. So any code outside of all the methods, that's going to run, and then this code is going to be called. So you're effectively adding to that initialization code. The context for this is inside this object that's being created. So we could do this.y or just y. The context is that object. So if we say y equals 10, we're doing the same thing as this.y equals 10, where this is the object that's being initialized. So if we run this code, we're creating a new physics vector at x equals 1, y equals 2, z equals 3. And then in the initialization code, we're going to say y equals 10. That's going to overwrite this 2, initialize that y to 10 instead, and then we're going to have a y of 10. So if you see braces right after a constructor call, that's adding more initialization code to that object initialization. I didn't expect that sentence to have so many buzzwords in it, but it's the way it ended up. So a block of code after the constructor, that's going to run to initialize this object that's being created. So it's fully customizable. If anything else we want to initialize, we can initialize whatever we want in there. Where this is really helpful is when we want to initialize variables, where we'll see it in the GUI classes. There are lots of state variables in these classes, and we want to initialize those outside of the constructor. So if we wanted to initialize those the way that we know how to already through the constructor, we would have to have constructors with like 20 parameters. And we'd have to specify all those parameters or give them defaults. If we give them defaults and we want to initialize the 17th one, we have to mirror those defaults all the way out to the 17th one and then set that value. It'd be messy, it'd be gross. With the initialization code, we can keep the constructors empty and then just let the user override the defaults with whatever variables they want using this syntax. So that's why it's used in this library. So let's look at our first GUI. Let's build that degree converter one step at a time. So here's our syntax of the program. This program here, if you run that, when it runs, this box will pop up, this window will pop up, and you have your very first GUI. You just created a brand new window through your code that your user can interact with. Of course, with this one, there's no interaction because there's no content in it. So to do this, the first thing we have to do is import all of our relevant code. This must be added to your pom.xml. If you're using the one from the examples repo, everything's already in there for the versions of Scala and Java in this class. So these should already be in your POM, and you can just create a new class in the examples repo and start playing with this code. You can import it without errors. It's already linked through your POM. So import any classes that you're going to use, and IntelliJ is pretty good about auto-importing. If you just start typing this code down here, it's going to auto-import, or at least notify you and say, hey, you got to import this stuff. Click this button and it'll import it for you. So import all the classes that we need, and we're going to create a new object, not a class, a new object that extends JFX app, a JavaFX app. So JavaFX app handles the main method, handles everything that we need to be able to run a GUI, and the only thing we have to specify is what the stage should be, which is a variable in the JFX app class, that whatever we put in that variable, that's what's going to be our GUI effectively. And then JFX app handles all of the stuff of how to render this, all the details that we don't want to be concerned about. So this .stage of the JFX app, we're going to extend that, get all the functionality, all the state and behavior of JFX app, which includes a state variable named stage. We're going to override that stage variable. Not override the keyword, but we're going to override the value in here. Whatever the default value is, we don't care what it is. We're going to override it with the details of our GUI. And to do that, we'll create a new primary stage, which is a class inside the ScalaFX library, and then use that initialization code. Here we don't even have the parentheses of a constructor based on the way that this class is set up, the primary stage class, and then we have this initialization code where we're going to overwrite any variables that we want. The title here is going to be whatever shows up in the window bar. And then scene is going to contain a list of all of the GUI elements that we want to add. That's where we're actually going to add the good stuff. That's where all the stuff goes. Oops, got ahead of my slide. So we want to populate the scene, the content of the scene, and you can see we have multiple layers of initialization code. Inside the primary stage, creating this object, we're initializing with this code, and inside that, we're setting its scene to a new scene and using an initialization code here as well, which is setting the content of the scene to a list of GUI elements is the next step that we want to do. So let's expand this a little bit and actually add some elements to our GUI. We're going to add our two text fields to the GUI. So with this, we're going to create text field classes where we're going to allow our user to input information, input text into our program. So we're going to import everything we need. And at this point, sometimes with the auto import can get you in trouble here. Sometimes the auto import is going to want to import the JavaFX versions of these objects, of these classes. It's important for all of these classes, all these GUI elements, to make sure you're importing the ScalaFX version. There are ScalaFX and JavaFX versions in the different packages that are going to have the same class and object names. Make sure you're importing the ScalaFX versions with one notable exception that we'll talk about later when we get to it. That was, especially when I had you writing GUIs for homeworks in previous semesters, that would be a common office hours question. What's going on? What's wrong with this? First thing I'd look at is the imports. I would see a JavaFX there. I'd say change that to Scala and fix their issue. So we're going to create our text fields, and we can override whatever we want. I'm going to take most of the default values, so I'm going to take the default size of these, mostly the width. I'm going to take the default size, default not default font, and override the font to whatever I want the font to be using JavaFX's syntax for fonts. For what it's worth, it's font FX, 18-point Arial font. Going to set it like that. And then for the output display, I don't want the user to be able to edit these, so I'm going to overwrite the editable variable to false. It's going to default to true. Most text fields, you want users to be able to input things. For this text field, I'm going to say, no, this is an output-only text field. I don't want you to be able to edit this information, so I'm going to set that value to false. And it's going to just not let the user select that. And then for our list that we're going to add down here, is going to take a list of elements, but if you just give it a list of elements, it's up to the scene to decide how those elements are organized. I don't want to leave it up to the scene. I want to define how they're organized. So I'm going to do that by adding a container of sorts, adding all my elements to a container, in this case, a vertical box, where I'm going to add a list of my elements, of my GUI elements, as its content state variable. And what this is going to do is take anything in this list, in this order, and display them vertically. So input display is going to be first, then output display is going to be underneath that. So it's going to list everything vertically, and there's a class HBox if you want things horizontally. And if you look at the point of sale GUI, I use a grid, which is going to specify the grid locations for all the buttons. Some buttons take up multiple cells in the grid, things like that. So you can get more advanced with that. We're only going to use vertical box for this and group later on in the next example. So with my vertical box, I'm going to add that to the content of the scene as just one element of the list, just one element, so I can control how it's structured with that one element. And then I get my GUI elements right here. And you could mix and match these if you want to have a vertical box with these two elements, and then the middle element is a horizontal box. You can get creative with how you organize things. Or just go to a grid when you need something fancier, like the button array for the homework assignment. Or tons of other ones. There's all kinds of classes, all kinds of ways to organize the content out there on the internet. You can find tons of examples. All right, so let's add our last element. Let's add a button to this GUI. I'm going to use the button class, very appropriately named, and I'm going to override whatever values I want in here. I'm going to override 4 different values here: min, width, mid, height. The width or height can be larger than the minimum if the text that I tell it to display just requires more space. It's going to expand that. But at a minimum, it's going to be 100 by 100 pixels. I'm going to change the font to 28-point Arial, and then display F to C, Fahrenheit to Celsius on the button. If I spelled out like Fahrenheit to Celsius, actually spelled everything out, then I wouldn't get my min width of 100. It would expand to be able to fit that text in there. So we set the minimum width, not the actual width, which is something to keep in mind if you're setting the widths. And then I'm going to add that to my vertical box. I'm going to put it right in the middle because, I don't know, that's where I feel like putting it. And our GUI looks the way it's supposed to look. Yeah, the unit is pixels on that 100. So we have our whole GUI set up. It looks the way it's supposed to look, but it doesn't do anything. It's kind of a problem. You can click that button all day. There's nothing in this code. This is the entire program. There's nothing in this code, well, except the imports. There's nothing in this code that says that button should convert degrees Fahrenheit to degrees Celsius. So we got to make it do that. So let's do that. So button, we're going to set a 5th variable of the button class. This variable is going to be the OnAction variable. This is an object that's going to be used whenever the button is clicked. Whenever the button's clicked, the button's going to look at its OnAction variable, and it's going to look for something which by default is no action at all. But if we set this to a different value, it's going to look for a value there and then defer to that for its behavior when it's clicked. What that has to be, what this has to be, what OnAction's type is is event handler of action event. So similar to how our lists and maps take type parameters, we have a class, event handler, that takes a type parameter. So we need an event handler of type action event, which will handle action events. The action is pressing the button. When that action occurs, we want to handle that event in some way. And how that's going to be handled is through this class, which is a class that we'll write on the next slide. So this new button listener, and I'm passing it input display, references to input display and output display. So this is a class that doesn't exist in the library. This is something that we write. Button listener has to be an event handler of type action event. It has to be. But I gave it a button listener, so how are we going to make that work? Good old inheritance and polymorphism. So we're going to extend event handler of action event. So this is an event handler of action event, and we can store it in a variable of type event handler of action event, which is nice because on action, that's exactly what type variable that is, event handler of action event. It's not of type button listener, but button listener extends event handler of action event. So that's perfectly valid assignment through the magic of polymorphism. So we're going to extend event handler. And this is the one exception to the everything should be ScalaFX. Whenever it's handler code, don't ask me why. I don't know. I looked into it. It's kind of a mess. These should be the JavaFX versions whenever you're working with events. If it's not, everything breaks, and it says that's the wrong type. So for what it's worth, this is the one class that should be Java. Any event-based code should be Java. So we're going to extend event handler of action event. This is going to contain, I believe it's a Java interface. It's going to contain one abstract method called handle, which takes an event of a type matching the type parameter. So this handle method is going to be called whenever we have to handle an action event. And we're going to get a reference to the event, which contains information about that event. For a button press, it's a button press. We don't really care about the details of that button press, at least not for this code. So we're not going to use the event here, but we do have to override the method named handle that takes an event, an action event, and returns unit. So we'll override that method, and that's the method that's going to be called whenever the button is pressed. So this is where we do whatever we want to do. In our case here, we want to convert degrees Fahrenheit to degrees Celsius. So at that point, it's however we want to code things with a little new GUI syntax that I'll talk about right now. To get the value that's displayed, I have this input display, which is a text field. It has a variable named text, which has a variable named value, and that's going to be the text that the user entered into that, the text that's currently displayed on that input display. For this one, it's whatever the user typed in there. And we're going to assume that they typed in a valid value. If somebody types in like cat into this field and presses the button, the program's going to crash. Or at least that thread is going to crash in this case, right? It's going to give you an error. The way the GUIs work, I don't think it does actually crash the program because it's multi-threaded. But we're going to get that value that the user typed in. And whenever we want to set the value, we do the same thing. We access that value and set it to whatever we want. This extra syntax right here, I'm using this to round to 2 decimal places, so I don't have truncation errors cluttering up the screen or infinite 0.33333 forever. I want to round it to 2 decimal places. So I'm using that using string formatting and saying, give me everything before the decimal point and 2 positions after the decimal point, and this is a floating point number that I want to give it, and you should get that from the variable Celsius. And the F says this is going to be a formatting string that I'm giving you. It's not just a string literal. It's a formatting string. So for what it's worth, I have that in there. And since this is a class, When you're overriding things like this and implementing interfaces like this, since this is a class, don't forget that you can use anything that you know about classes. This class could have extra state variables. You can add extra state variables here. We're already using the constructor. We can have helper methods in here. We can do anything that we can do with other classes. We could add the whole state pattern into this button listener if we want to. You're not restricted. It's nothing special just because it's extending an event handler. The only thing that this does is say this class has to implement this method because that's an abstract method in the event handler of action event class. That's it. Everything else, it's a regular class. You can do all of your regular class things, including writing more methods like we do here. So that's where all of your coding expertise comes into play. Code whatever the hell you want in these things. As long as you implement that one handle method, everything else is everything you would do with any other class ever. And that's your first GUI example. It goes quick because there's another example I want to get through. So let's pause for a second here. Are there any questions about any of this? Between this and the button listener. So we used polymorphism and inheritance right here to set OnAction to whatever we want it to be. OnAction is of type event handler of action event, but we use polymorphism to create our own class that does whatever we want it to do, whatever action we want to happen when that button is pressed. We're passing references to our text fields, so we have access to both of these text fields whenever the button is pressed, and we can manipulate the values of those text fields. And this is an example to show that you can do whatever you want. Whatever you can code when that button is pressed, that's what that button can do. Literally anything. You can make a network call and access a network database. It can do whatever you want it to do. These classes are all in the repo. Yeah, you don't have to write these, if that's what you're asking, paper me. But this is all in the repo. In LO2, I believe the package is just called GUI, I believe it is. And this and the next example are both in there. The next example is actually the one you ran on week 2 in lab. So you already are familiar with at least what that's supposed to do. We're going to go over the details of it. But you don't have to write any GUIs in this class. I used to have you write GUIs. I don't know. It was never worth it from an educational standpoint. The one big thing that I want you to get out of it is we're leveraging polymorphism right here. Polymorphism and inheritance are still happening. And that's why we talk about GUIs right here, because now that you know inheritance and polymorphism, I can show you a bunch more cool stuff. Like, I can't meaningfully talk about GUIs before then because I get to this point and you're like, the hell's extends? I do that once with testing. I show you the keyword extends before you're introduced to it, just because we need to do testing before. But with GUIs, this is the place for it. This is where we can first meaningfully talk about GUIs. Because any GUI, not just this library, but any GUI library, has to have some way around this. They're either going to use polymorphism and inheritance or functional programming. They're going to have some way of having you define the behavior based on an event that occurs in the program. And this library does it with polymorphism, as most do. Are there any built-in classes Jesse didn't write? So sample GUI and button listener are the only 2 classes I wrote for this entire example. Everything else is in the libraries. So everything else, like the text field class, the button class, VBox, primary stage, scene, JFX app, event handler of action event, all of those classes are imported from ScalaFX, or in one case, JavaFX, from the libraries. And I did not write any of those. Those are all from the libraries. The only 2 classes I wrote is button listener and sample GUI. So I've shown all the code. In this example, I didn't hold anything back. I showed you all of the code that I wrote for this GUI. If you just write that code, you get a GUI with functionality. It's actually, you might think it's more complicated to write a GUI if you first think about, like, how the hell do we write a GUI? Pull in this library, and then it's not too complicated. To get all the syntax, I'm sure you wouldn't be able to just go into IntelliJ and write this without staring at the slide. To get all the syntax down would take a long time. But going off an example and then modifying this example to do what you want it to do, not ridiculously hard. Hard enough that I got sick of having it for assignments because it was painful. It just cluttered up office hours with topics, questions not related to the concepts of the course, questions not related to inheritance and polymorphism. Okay, so buttons are cool, but what if we want more graphics? What if we want to really get that graphical part of a graphical user interface? Let's jump into it. So a note on graphics, before we jump into anything, this is something that threw me off when first learning graphics. The origin of a screen or an image or a video, this is standard across computer science, across computers. The origin is in the upper left corner. That's 0, 0 up in the upper left corner. This screen right here, 0, 0, pixel 0, 0 is that upper left corner way up there. It's just the way it is. That's the way images are. That's the way we roll in computer science for images, for anything graphical. So that's the origin. The y-axis is pointing down, and the x-axis is how we would expect it to be, pointing to the right. So the y-axis is inverted, though. It's something important to keep in mind. Whenever we're dealing with y-axis, as y increases, you're going down the screen. Just the way it is, and we're gonna live with that. So if you're coming from math class, if all you've ever seen is y-axis going up, just know that that's not necessarily a standard. In math, visually, that's how we represent it. It's not necessarily a standard. As you go into different fields, axis systems are going to be strange, especially when you get into the world of 3D. What's up? What axis is up? From what I can tell, nobody can agree on what up is. In my examples, I do up as positive z. Positive y is a common example. I've seen negative z. I've seen negative y. A lot of libraries have different axis systems. So some of them get distorted from what you're used to. For images, 2D images, this is standard, though. 3D, we don't know. We can't agree on anything. But 2D, origin is upper left. And then to create shapes, we're going to pull in some more classes. Circle and rectangle I have up here. And this is an example of how to use them. I don't have much to say about this. I think it's pretty self-explanatory, except circles, you're defining by the center and how big it is, by radius. And a rectangle, you're specifying the upper left corner of the rectangle and then the width and height of the rectangle. So we're going to go 60 over, well, let me make it more accurate. 60 over and 10 down. That's going to be the start of the rectangle, and then 60 over and 40 down to specify the size of the rectangle. So that's how the rectangles are specified. Where the circle is going over 20 and down 50, and then a radius of 20 to get the circle. And the fill, green and blue are named constants, so I'm doing color.green, color.blue to be able to get those standard colors. And then when we create circles and rectangles and all these shapes and all these graphics, it gets less meaningful to organize them in like a vertical box, a horizontal box, or a grid or anything. That doesn't quite make sense since we're specifying exactly where these shapes should be based on where the center of the circle is, where the upper left corner of the rectangle is, and the size of them. So it doesn't really make sense to say these should be arranged vertically because we've already specified their exact locations and sizes and everything about them. So instead of adding them into like a vertical box, a horizontal box, a grid, we're going to add them into a group, which is just a group of GUI containers, a group of GUI elements with no meaningful organization. We're going to leave it up to each element itself to figure out where it should be displayed on the GUI. So add them all to a group, and then add the group to our scene. And here's the full code of that. And let's pick apart the parts we didn't talk about. We already talked about creating circles, the group. I guess that's about it. And the scene. So let's talk about the extra parts here. So when we add these elements to the screen, so let's back up to the degree converter. When we added the degree converter GUI elements to the window knew to resize to be able to fit all of those elements to the screen, and it didn't get any bigger than that, any smaller than that. The window size was exactly where we want it to just barely fit all those elements in. Now that we're in graphics and these graphics can move around, we don't want to leave it up to where their positions are to be able to set the window size. So we're going to explicitly state the window size. I'm going to say this is going to be an 800 by 600 window. Now, no matter where my graphics start, I'm always going to get the same size area to work with, and then I can move my graphics around in there. So maybe this is a game, and that's the size of the game area. That's what I want, 800 by 600 pixels, and then I can move my characters and game elements around that. I'm going to create a player as a circle, and then add to the scene. I'm going to specify the width and height, and then add the scene graphics to the scene like we did before as a group. And I want to highlight this part right here. I have this update. Let's talk about what that does. So this update, or action timer, I should say animation timer. My animation timer, something that I'm going to use to have animations, so things can move around in my GUI. This is going to take in its constructor a function, could be a method, but a function. This is the first time we're seeing an actual function in this class that takes a long and returns unit. This method is going to be called, ScalaFX will do everything it can, JavaFX will do everything it can, to call this method 60 times per second. So we're going to run it 60 FPS. And the long that this method takes is going to be the number of nanoseconds since the epoch, which is January 1st, 1970. So this is a Unix timestamp, we usually call them. And it can be used to figure out how much time has elapsed. So if you remember the last time that this function was called, remember what that time was, the nanosecond since the epoch, and then take the new time it's called, subtract. Now you have the elapsed time, which should be roughly 1/60th of a second. And then you can compute the exact time, and then advance all your animations by that much time. I'm not going to do all that in this example. I have to fit it on a slide. So I'll just update, kind of assume that it's 1/60th of a second and update based on that. But this function is going to be called every 60th of a second if possible. Obviously, if you have a lot of slow code, it might have some lag and you might skip some frames and stuff like that. But it's going to attempt to call it 60 times per second, and I'm going to call start on that to start the timer. The function that I'm giving it, let me see if I'm getting ahead of my slides. The function that I'm giving it, and we'll talk about this syntax a lot more in functional programming, but I want to kind of tease it right here. I'm going to create a function that takes a long and returns unit, and I'm going to specify what that should do right here. And what it should do is I'm going to iterate over all my rectangles, and I'm going to rotate them by half a degree. So every 60th of a second, I'm going to rotate them half a degree. I should get 30 degrees of rotation per second, so I'll have some nice spinning rectangles as this program's running, which is cool and all, but we don't have any rectangles. So let's add a way to get rectangles. We're not going to add any rectangles directly to the GUI. We're going to let our users do that. So our users are going to add to the GUI by adding an event handler that listens for mouse events. We're going to add an event handler to the scene that's listening for every time the mouse is clicked. And we're going to give it a new mouse event handler, which is a class that I wrote, which has to extend event handler of type mouse event. So just like we were listening for button presses with action events, now we're going to listen for mouse clicks using the mouse event. And this time we actually are going to use some information from the event. We want the X and Y location of the mouse click. So we're going to get the X and Y location of the mouse click and add a rectangle right there. We're going to have our add rectangle like we did before, but a little extra code to offset so the click is where the center of the rectangle will be. So we're offsetting the rectangle a little bit. And then adding them to our data structures of our GUI 2D object. In the interest of time, I got to jump ahead a little bit. We did explain all that. So now the user can click, add rectangles. Those rectangles should be spinning, like you saw in lab on week 2. And like you can see if you run it right now, you can pull it up on the repo and run it right now. You'll click, and the rectangles will spin. And one more feature that it has, we can also add key event listeners. So we can listen for, or handlers. So we can listen for key events. Whenever a key is pressed, I'm going to call this key event handler's handle method. I'm going to extend event handler of key event. And for this, I want to move the player around. I'm going to check using a match case statement. We saw this very briefly when we talked about overriding equals, the equals method. We're going to check what the name of the key that was pressed was, whether it's WASD, and we're going to move the player in the appropriate direction when that key is pressed. Or held down, it'll keep calling this. If a key is held down, it'll keep calling key pressed. So if you hold down the key, the player will keep moving. So if you use the WASD, that blue circle should move around the screen. Which is my last slide. And then it just ends. All right, and good, because we were less than a minute left. So that's GUIs. Again, you're not asked to write GUIs, but there's a lot of fun stuff to do here. There's a lot of stuff you can build with GUIs, with everything you know about programming, and now slapping GUIs on top of it and making like real life programs. See everyone Friday.